All right, let's go ahead and do a B6, sketch the graph of the inverse of the function. We're first going to do the parent, then the transformations, and then the trick. Rotate it 90 degrees counterclockwise, which is going towards the left, and reflect it over the y-axis. Let's go ahead and do that. So the first one I have here is x to the fourth. This is a power function, so if you put in x equals 0, you get 0. 1 to the fourth power is 1, and 2 to the fourth power is 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16, so way off the charts. Negative 1 to the fourth power is 1, and negative 2 to the fourth power 416. So here is our parent graph. Make sure those points are distinct so you can see those. And then the next thing I'm going to do is apply the transformation, which is a 1/2. What it does, it basically shrinks or vertically compresses the graph. Okay, so if my graph was at 1, what's half of that? Well, half. What was half of 16? It's that magical number we've been using a lot today, is 8. And then you can just use symmetrical or mirroring on the other side for that. So it didn't change it too much at all. Okay, what are we going to do next is we're going to rotate the graph towards the left 90 degrees or counterclockwise. So it's still here, and my point now is at half, and at 2, it's going to be 8. 2, 4, 6, 8. And then over here, doing the same thing. 2, and over here. So what's happening is, there it is. And then the last thing we need to do is reflect it over the y-axis. So go over the pink dotted line. The points are just going to swing over there. So from the light blue, and then we need to go towards 8 here. And this is what my graph's going to look like. So even the properties we learned last semester about power functions, well, it's in even degrees, so those arrows are in the same locations. Should have came up like that. All right, so that is our graph there for B6.